We're going to introduce the concept of a hypothesis test by looking at a specific example. So how would you determine whether a coin is probably biased towards heads? So the first thing that we need to do is we need to rephrase this as a probability. So we think that the probability of getting heads is more than a half. Next, we're going to work out what data we're going to collect in order to either support this claim or actually say that the coin is probably fair. So what we're going to do is we're going to flip the coin a certain number of times and count how many heads we get. Let's say that we're going to flip the coin 10 times. So our random variable x is going to be the number of heads when we flip the coin 10 times. Next, we're going to write down our alternative and null hypotheses. So our null hypothesis is that the coin is just an ordinary coin and it's actually fair. Our alternative hypothesis is what we think is true, which we think that the probability of getting heads is more than a half, so p is greater than a half. And at this point, it's worth noting what values of x will help us support this alternative hypothesis. Well, if we think the probability of heads is greater than a half, then x is going to be large. We're going to get lots of heads. So let's say x is large. If x is large, this supports h1. And next, what we're going to do, so the way that a hypothesis test works is we're going to assume that h0 is true. So assume the null is true. So that means that actually the number of heads that we get will be binomially distributed with 10 trials, and the probability of getting heads, if we assume h0 is true, is going to be a half. Well, it's worth noting, if this is true, so if the coin is fair, we would expect 5 heads. Half the time we're going to get heads. Now, obviously, we're not going to get exactly 5 heads each time, but it'll be close to 5. So what we're going to do is we're going to look at what this distribution is, this null distribution, and we're going to work out what values of x are really unlikely, which will lead us to conclude that actually the coin's not fair. So let's look at the distribution. So here we've got our null distribution, which is that the coin is fair and it's binomial 10 a half. And you can see that for these values of x are quite unlikely. So if the coin is fair, it's really unlikely that we get 9 heads, for example. The probability is much less than 0.05, maybe about 1% or something like that. And 10 is even more unlikely if the coin is fair to get 10 heads. So what we're going to do is we're going to define what's called a critical region. So a critical region. Another word for critical region would be a rejection region. And this is basically saying what values of x can I have where I conclude that they're so unlikely that we can reject h0 and actually say that h1 is probably true, which is why it's called the rejection region, because you can reject h0. So in the next video, we're going to look at how you define this, but one rejection region could be x is greater than or equal to 8. So what we could do is we could work out what's the probability under this distribution for a fair coin of being in this region here. And that probability there of being x being greater or equal to 8 if the coin is fair is 5.5%. So that basically says if you land in this region here, you get 8, 9 or 10 heads, then it's only a 5% chance that that would happen if the coin's fair. So it seems reasonable that if you land on 8, if you have 8, 9 or 10 heads, then it's pretty unlikely that the coin is fair because there's only a 5.5% chance that you'd have that. Another critical region might be that you demand that you have 9 or 10 heads. And we could work out the probability of x being greater or equal to 9. And that probability is 1.1%. So you can see that if I made this my critical region, my rejection region, then it's even more unlikely that I'd be just in this region with 9 or 10 heads. So if I landed in this region, I could be even more certain that I should reject H0 and say actually the coin is not fair and that heads comes up more than half the time. Now these percentages here are called the significance level. So the significance level here was 1.1%. The significance level here was 5.5%. And the smaller the significance level, the more extreme the value of x that you need to see is. So if the significance level was 1.1%, then you'd need to see 9 or 10 heads. But if you relax that a little bit and said actually the significance level only needs to be 5.5%, then you could reject H0 if you had 8, 9 or 10 heads and conclude that head comes up more than half.